So a town has a population of 18,000 that grows at 3% per year. What will be the population in 6 years? All right, so again, a town has a population of 3%, I'm sorry, a population of 18,000 growing at a rate of 3% per year. What is the population in 6 years? Well, it's growing, so it's going to be more than 18,000, of course. We're going to use this formula. Okay, we're trying to find the final amount. So we want to write y equals, we want to know the final amount with an initial amount of 18,000. That's our A, right? Our initial amount. Our B is a 3% growth. So that's 1.03 because it's 1 plus 3%. 3% is 0.03. And our time is 6 years. So break out those calculators and let's figure out what this is going to be.
I have a question.
Yes.
I don't get how you get the B.
Yeah, so the B is 1 plus the rate. So if it's growing at 3%, remember 3% as a decimal is 0.03, right? And so then it's our B is 1 plus 0.03, which is 1.03.
Okay, thank you.
Okay. Yeah. All right, so then we would plug that into our calculator. Where is my calculator? All right, so 18,000 times and where are we? 1.03. Sorry, it's been too long since I've used this calculator. To the sixth. And there it is, 21,492.9. But we're talking about people here, right? So we would have to then round that to 21,493. That would be our new population.
So why is the 6 like not multiplied, but it's like an exponent?
Yeah, the 6 is, that is your time. So like here, remember X is your time.
Oh,
okay.
Yeah, okay, now I understand.
Yep. All right, good questions. Anything else? Any other questions? We'll do another one, of course. All right, well, let's do then another one. Maybe we'll do a decay here. All right, let's say a car is purchased for all right, let's say $21,800. Nice car, right? And you know, cars always depreciate. They go down in value. Not always, but almost always. And depreciates 9% per year. And unfortunately, that's a fairly accurate number for many cars. So a car is purchased for $21,800, but now it is depreciating at 9% per year. How much will it be worth in 10 years? Let's say 8 years. How much is it worth in 8 years? So a car is purchased for $21,800. It's depreciating at 9%, so it's going to be 1 minus that rate. And then how much is it worth in 8 years? 8 will now be our exponent. So we are trying to find our final amount with our initial amount of 21,800. And now this number is going to be 1 minus 9%. So I wrote that as 0.91 to the 8th power. Now, if that's hanging you up, if that 0.91, and I know we had that question before, if that's hanging you up, you can write it out actually, because we're using our calculators. You could write it as 1 minus 0.09 to the 8th. And that would, you can just plug that right into your calculator. It's the exact same thing. So let's figure that out. It's 21,800 depreciating at 9%. So it's going down now. So our answer should be less than that, right? So 21,800 times 1 minus 0.09 or 0.91, okay, which is how I wrote it. And then that was, how many years did we say?
8.
8 years. Okay, thank you. I just don't want to flip back and forth to the 8th power. So it is now worth $10,251.50. Okay, and that's money, so we would write it as money. So $10,251.50. All right, any questions before I have you guys try a couple on a class kick? So for the first one, we have a new car purchased at $2,300. That's our initial amount. And it's depreciating at 8.75. So we have 1 minus 0.0875. Some of you forgot the 0.0875 and just wrote 1 minus 870 or 8.75. So don't forget that that is written as a percentage. And then to the 12th power. You can plug this into your calculator just the way it looks. Just to show you that when you do the 1 minus 0.0875, you get 0.9125. You can plug it in that way also. Okay, either way, your final answer should be $6,735.35. And now we're talking about money, so we would write it exactly that way. Okay, any questions on that one?
Oh my gosh, I understand now. I wasn't doing percentage. I was just putting the number in.
Yeah, really common mistake. That's okay. But it's good that you notice, like, hey, my answer was way off. So it's good that you're processing that.
Mr. O'Connor, I have a question on the third one.
Okay. Why don't you wait, Sadiqa, or do you, what, is it a quick one? What do you got?
Yeah, like it's quick. Like it says 15 minutes, but the other one it's like per year. But is it still the same? Like, do we just do it to the power of the 15?
Yes.
Okay.
Yep. All right. So for the next one, we have our initial amount is 14,000. I should have written y equals. With 14,000 is how many people we started with, but now we are growing. So it's 1 plus 0.035. and after 14 years. And so you could type it in this way, or you could add that together and write it as 0.1035. But that would be our formula. And in either case, our final answer should be 22,661.7. But since we're talking about people, we're not going to have 0.7 people, right? So we should round that up. So you want to round that. It says to the nearest whole number, of course. All right, last but not least, we have an element with a mass of 210 grams. So that's our initial amount. It's decaying by 8.3%. So that's 1 minus 0.083%. And how much is remaining after 15 minutes? So that would be our formula. And if you plug that into your calculator, it says how much is left to the nearest 10th of a gram. So that comes out to be 57.2479. So we would just say 57.2, and that would be our final answer. All right, any questions on that? So again, and you can notice from the rates, that this one was decreasing because that number was less than 1. And this one was increasing because that number was greater than 1. So this is growing and this one is decaying.